Now let's work on this assignment, two-way signaling in producer and consumer scenario. Let's jump into Visual Studio right away. First of all, we will need to focus on the producer, which is the main thread, as I mentioned in the requirement. We're going to have a while loop, and then inside the loop, we are going to produce. So first of all, we're going to have a write line, and I'm going to say, in order to produce, enter letter P. And then we're going to read the input from the console, just like this. And if it's null for whatever reason, use empty string. And here we're going to use the if statement. So if the input, maybe do a 2 lower, just like before. So 2 lower, and if the input is letter P, then what are we going to do? We are going to produce a batch of food. Remember? I'm going to say from 1 to 10. Let's say each batch has only 10 items, just so that we can debug, right? We don't want to see like thousands of items on the screen. And then we're going to say queue.enqueue. So here we need to declare a queue. This represents the feeding station in the farmer and pigs scenario. So we're going to have a queue. We can use a regular queue, and it's going to be a queue of number. And then I'm going to say queue equals new queue. Looks like this collection is not being used, so I'm going to do a control dot to just remove unnecessary using statements. So here I'm going to do a enqueue. So I'm just enqueue I, and then I'm providing a message here. I have produced I. So once this finishes, I want to signal the worker threads that I've produced a batch and go ahead and consume it. So because of that, we need to declare a event. That's going to be a manual event. So I'm going to say manual reset event slim, and I'm going to call this consume event. And the initial state is false, right? It's only turned true, right? Turned on when this is ready, right? When the batch is ready. So I'm going to do the set. Now we come back and focus on the worker threads. So come back over here, maybe just above this. Well, we had to do it above this, right? Because this is the main thread, and this is going to be blocking because it's a infinite loop. Okay, so here we're going to have a array of consumer threads. So I'm going to say 3, okay? And I'm going to have a for loop that produces those 3 different threads. So from 0 to 3, to 2, and I++. And over here, I'm going to say consumer threads, I equals new thread. And the work that the thread is going to do is going to be called consume, which I haven't created, but I'm going to write it here. So consumer I to start. Before I start it, I want to give it a name, just so that when I output, I can see the name. So dot name equals consumer, and which consumer? It is the consumer I. All right. Now I'm going to have a comment, so this is producer. Now we're going to define the consumer's behavior. So void and then consume. So this is the task that the consumer is going to perform. So again, this consumer is going to do a while loop as well, so that it just does not exit. And when you produce another batch, they're ready to work on it again. Here, we're going to use the consume event, right? Because we need to be blocked if it's not signaled yet, if the batch is not ready. So only when the batch is ready, which is starting from line 40, do I need to take a look at the queue. Right? So I'm going to say, well, and then I'm going to say queue.try, and so out var input. I'm not going to use this automatically generated code. I'm going to say int item. So I know it's integer, so I'm going to use its integer. Okay, so here within this while loop, this is where the work is, right? So work on the items produced. I don't want to just dequeue one of them. I want to keep getting it if it's available for me. Okay, so I'm going to say thread.sleep. Maybe sleep for maybe half a second. So I'm going to say console.writeLine, and then this is announcing to the world that I'm consuming, so not consuming, I'm consumed. I have consumed which item, this item, from which thread, from myself. So I say thread.currentThread.name. Now, as I mentioned, if you worry about this thread safety of the queue object, it's because it's a regular queue that you can use a lock to protect the in queue and the DQ. For now, we're not going to worry too much about it. If this is a real world scenario, of course, I encourage you to protect it, a lock. However, in the real world scenario, you wouldn't use a regular queue. You can use the concurrent queue. We're going to talk about that later, as I mentioned. Now, the problem is that how does the producer know that the consumers have finished consuming all of the items in the queue, right? All of the food in the food station. There has to be a signal from the consumer to the producer. So right now, we already have a consume event. So this is used to signal from the producer to the consumer, so that the consumers can go ahead and consume whatever that is in the queue. Right now, the queue is empty. When the queue is empty, the consumer needs to send a signal back to the producer. And for that purpose, we need to create a second. So let's copy this and just paste it. And here, we're going to say, instead of consume event, I'm going to say produce event. And we're going to turn this on at the beginning. What does this mean? So initial state is true. When the initial state is true, that means we allow whoever is waiting to enter directly. So that means the producer, if the producer is waiting, then the producer can directly go ahead and produce. That's the initial state. If we don't have this to true and apply a wait here, right? So let's say I'm gonna apply a wait here, produce event, and I'm gonna just say wait. Then if this is false, then the program will just stay there. This is gonna be blocked, and it's gonna be blocked forever, and that's not right. At the beginning, we have to say true in order to let the program go to the next line. What we can do here, we can say produce the event, and then we can say reset. Reset means we're going to turn it off, because I already produced. I don't want to produce again until the queue is empty. That's why we have a reset. And what this means is that once all of this finishes and come back to the while loop, right, because it's while true, so it's going to come here and execute this, and it's going to be blocked because this line has already been executed once. So here it's going to be blocking. Then the consumer has the responsibility to tell the producer that when the queue is empty. The problem is how? How does the consumer know the queue is empty? We might think it's easy because when the code execute over here, it just means that the queue is already empty. Otherwise, it's going to be in the while loop. It's always going to consume all of the items in the queue before it comes over here. So over here, we can just say produce event dot set. Right? Once we set it, it just means that the signal is on. And at that moment, if the main thread is being blocked over here, it's going to just come over here, right? And it says to produce, enter P, and then it's going to be blocked again on the IO on line 22. So at that moment, if the user press P and hit enter, then the whole thing happens again. However, there could be a problem in here because remember, we have three different threads. Three different threads represents three little pigs, and each one may execute this, which may cause overproducing, right? Overproduction, and we don't want to do that. So in order to avoid that, we can create a counter. So maybe come over here at the top, we can have a consumer count set to 0. So, and then over here at the end, we can say consume event, not consume event. We can say consumer count increment by 1. And then if the consumer count equals to 3, that means that all of the three little pigs, right, all of the three worker threads have already finished this while loop. That means that the queue is empty. And only when the consumer count equals to 3 do we set it. So we can move this into if statement here. And then we can set it to 0. And now we can console on the right line. We can say, just make it clearer, have this. And then we can say something over here in the middle. We can say that more please. Okay, more food please. And then here, some more stars. Okay, this seems to be right. However, there's a couple of more things we need to talk about. Right? So we use the produce event.set to signal back. We use the reset in the main thread here to turn the signal off. So we have this consume event, which we never call reset to turn it off. Remember, it's a menu event, so we have to turn it off. So where do we turn it off? Right, we can't turn it off right here. So let's go up here. And producer here, you can see that we directly turn it off. Well, that's just because we have only one producer. Here, you can't say consume event and reset. If you do it this way, there could be only one consumer, only one worker thread working for this entire application. And we don't want to do that. We want to utilize the multiple threads. And therefore, we think that here could be a good place, right? So when I say consume event, not uppercase, I'm going to say consume event, and I'm going to say reset. So here we are turning off the signal so that no other threads can enter anymore. And this allows the producer to signal it again. So if we don't do the reset, then the signal is always on. So that doesn't make sense. So we have to call the reset to turn it off, allowing the producer to have enough time to produce a batch. And then here, the consumer, one of the consumer, signals back to the producer and saying, give me more, right? Now, the second thing I want to mention is because this is multi-threading, right? The consume is a task that is performed by 3 different threads. Therefore, this line, they are considered critical section, right? So we need to use a lock to protect it. So let's go up here and let's create a lock. So I'm going to say lock object, or maybe say lock consumer count, which makes more sense, equals new object, and then come back over here. And we have to protect, so lock like that, and then are going to move all of that to in between. All right, so that's the implementation. Let's run the program and see whether it works or not. Let me increase the font, and if I say P and hit enter, you can say produced 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it consumed 3 from thread 1. So thread 1 consumed 3. Thread 0, why it says thread 0? So let's fix that problem. So it's from 0 to 2, therefore this has to be increased by 1. Okay, let's try it again. Let's increase the font, press P. All right. So thread 2 consumed 1. Thread 1 consumed 2. And you can see that all of the 3 different threads are involved, and they consumed 1, 2, 3, 4, 5, 6, 7, 8, 9. What about 10? Oh, here. 10 is here. Right, consumer 3 consumed 10. And then one of the threads, I think this is the consumer 2, reached the consumer count equals to 3 scenario. Therefore, it says more please. And then it gives the signal and say to produce, enter P. So when it comes to here, that means that our main thread has been waiting over here. And because thread number 2 gives the signal, therefore it comes to this line and currently blocked on here. Now here, if I do P again, you can see that 10 different numbers are produced. And then the consumption begins by 3 different threads. and this consumption is different. You can see this is consumer number 2 starts first, and this is consumer number 3 starts first, and it consumes the number 3. Right, so this one consumer number 2 start first, and consumer number 1. So it's random. Right? There's no pattern. And over here again, more please. So it signal back to the main thread and says, give me more. Now I am the producer. I have the power to produce or not, or maybe just keep them hungry for a little bit. And after some time, I think it's ready. Then I press P and hit enter. Now another batch is produced. So this is the implementation. And in this implementation, we learned about using 2 different events to have two-way signaling between producer and consumer. And we learn about using the reset method to turn off the signal when we need to turn it off. Okay, that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one.